Welcome to AgriBot channel. Today we are looking at a very practical broccoli success story from Mizoram, where better nutrient management and smart low-cost irrigation helped farmers increase yield and income. If you want to understand how balanced fertilizer use, organic manures, and gravity-based sprinklers work together in hilly areas, this case is worth watching. Broccoli is becoming popular in Mizoram because it is nutritious, profitable, and has strong market demand. But the productivity in the state was only 7.65 metric tons per hectare, much lower than the national average of 17.34. That gap clearly showed that farmers needed better varieties, better crop management, and more balanced input use. This is where integrated nutrient management and proper irrigation became very important. The low yield was not due to one reason alone. Farmers were facing issues like poor access to suitable high-yielding or hybrid varieties, lack of technical guidance, and unbalanced use of fertilizers and other critical inputs. In such situations, field demonstrations are more useful than only classroom advice because farmers can directly see the results. That is why the demonstration approach taken in Mizoram was so relevant. Krishi Vigyan Kendra, Aizawl conducted cluster frontline demonstrations from 2018 to 2020 using broccoli variety CLX 3512. The program covered 40 hectares and involved 120 farmers under the TSP program. This was not a small trial on one farm, but a cluster-based effort that gave a real picture of field performance. The focus was on combining integrated nutrient management with a gravity-based mini sprinkler system. The nursery was raised in a community participatory mode, which helped farmers share labor and planting material. Nursery beds were prepared with well-rotten FYM or vermicompost at 4 to 5 kilograms per square meter, and the bed width was kept at 75 to 100 centimeters. To prevent damping off, the bed was drenched with INM 45 at 2 grams per liter of water. Seeds were sown in rows 6 to 8 centimeters apart at around 800 to 850 seeds per square meter, then covered lightly with sand, soil, and compost mixture. Seedlings were transplanted after 26 days with spacing maintained at 45 by 50 centimeters for proper plant growth and head development. A light irrigation was given immediately after planting to help establishment. Weed control was managed through 2 manual weedings at 20 and 40 days after transplanting. For insect pests, especially cabbage butterfly larvae, manual picking was done first, followed by spraying chlorpyrifos or Rogar at 3 milliliters per liter when needed. The recommended INM package was very specific. NPK at 75 hours 38 minutes and 30 seconds kilograms per hectare, plus poultry manure at 2.5 tons per hectare, vermicompost at 2.5 tons per hectare, and slaked lime at 2 tons per hectare. All phosphorus, potassium, and 1/3 nitrogen were applied before transplanting. The organic manures were thoroughly mixed into the topsoil, which improves nutrient supply and soil health. The remaining nitrogen was top-dressed in 2 equal splits at 15 to 20 days and 30 to 35 days after transplanting, along with earthing up. A very important part of this model was water harvesting and efficient irrigation. Water was stored in a micro-water harvesting pond, or jalkund, with a capacity of 27,000 liters, especially useful during the lean period from October to January. The mini sprinkler system used 16 mm laterals, a 32 mm main line, screen filter, and sprinkler stakes raised 1 to 1.5 meters using bamboo. The calibrated discharge was 50 liters per hour, and irrigation was scheduled twice a week, which is a practical solution for hilly terrain. The results were quite impressive. The demonstration plots produced 243 quintals per hectare, compared to 164 quintals per hectare in the local check. Even though the cost of cultivation was higher in the demonstration plot, at about 121,525 rupees per hectare versus 96,000 rupees in the check, the returns were much better. Net profit reached 558,875 rupees per hectare in the demonstration, compared with 324,550 rupees in the local practice, showing that better management paid off clearly. This technology did not remain limited to the original demonstration area. Because farmers saw bigger broccoli heads, higher yield and better income, neighboring villages also began adopting the model. The article notes that 64 farmers adopted the technology, which shows strong confidence in the results. The biggest lesson here is simple. Balanced nutrition, local organic resources, and efficient irrigation together can transform vegetable production in difficult hilly regions. So the big takeaway is that integrated nutrient management, combined with gravity-based mini sprinklers, can significantly improve broccoli yield and profitability in Mizoram-like conditions. If you found this useful, like the video, share it with fellow farmers and agriculture students, and subscribe to AgriBot channel for more practical farming success stories.